When you interact with a large language model today, it is trapped inside a web interface. It generates text, but cannot take action. If you ask it to write a Python script, you are forced to manually highlight, copy, and paste that output into your actual working environment to see if it runs. This is intentional. Web browsers operate as strict sandboxes. They physically isolate whatever happens inside a web tab from your computer's underlying operating system. For an AI model to execute real workflows, it has to escape that isolation. That escape route is the command line interface, or CLI. It is the unfiltered frontier for AI integration. Moving an AI into the terminal changes its mechanical function. It ceases to be an advisory chatbot and becomes an active system operator. Instead of typing a prompt to ask an AI how to fix a crashed web server, you deploy the local AI to actually restart the server itself. The terminal grants the AI direct access to the system, providing a mechanical interface for physical file manipulation and networking. Delegating execution to an agent forces a complete reevaluation of what software engineers and system architects actually do all day. Moving into the terminal is the specific mechanical step required to transition from passive tools to autonomous execution. This diagram illustrates the technical boundaries of a modern machine. At the top is the user space, where standard applications and web browsers are heavily contained. Operating systems enforce an active barrier right here, ensuring that arbitrary code running on a web page cannot reach down into your deep system files. The command line shell sits beneath that protective web sandbox. It inherently operates with elevated privileges. From the CLI, pathways route directly into the core operating system components, including your local storage arrays and networking protocols. It also provides direct access to your package managers and environment configurations. Installing a local AI agent means you are piping the analytical outputs of a large language model straight into these unrestricted execution pathways. You can instruct the agent to analyze a bloated local directory, and it will read the contents, categorize the logic, and execute the restructuring scripts entirely on its own. By connecting directly to native operating system pathways, the model steps out of its consultant role and begins acting as a capable digital mechanic. In the early days of computing, writing software meant physically inputting raw assembly code and rigid syntax by hand. Engineers working before the 1970s were bound by an incredibly slow, manual execution pace. Every single hardware instruction required explicit human input. Then came the invention of the programming compiler, popularized by pioneers like Dennis Ritchie with the C language. Many early developers argued that abstracting machine code into readable text would make their skills obsolete. They thought automation would kill programming. Instead, automating the syntax layer allowed a single engineer to output exponentially more logic in a fraction of the time. We are experiencing a parallel transition right now, driven by integrating Agentic AI into the terminal. This integration relies heavily on the concept of an AI skill. An AI skill functions as a standalone executable script, allowing the model to perform a defined local workflow upon request. Agentic AI is acting as a multiplier. It functions as a modern compiler for system architecture and high-level logic. The day-to-day reality of software engineering is shifting from typing raw syntax to orchestrating these autonomous AI skills. This technical migration to the command line is currently accelerating because of severe corporate warfare between major tech providers. Google command an enormous physical and financial footprint, allowing them to fund a highly aggressive development strategy. They routinely isolate multiple engineering teams and assign them to solve the exact same technical problems simultaneously. This corporate ecosystem map illustrates the structure. Inside Alphabet, these separate teams operate as independent nodes, actively competing against each other for computing resources and internal adoption. The result is highly Darwinian. Projects that fail to generate traction or overlap too heavily are simply shut down, leaving only the most efficient survivor to scale. This internal pressure peaked when competitors like Anthropic's Claude bypassed the browser's speed limitations, delivering direct-to-terminal tools that developers adopted for raw execution speed. To survive the internal call, Google's teams had to match that low-level access. Establishing residency inside the developer's local terminal is currently the most valuable real estate in the AI market. The deployment of CLI agents is a forced evolutionary response to fast-moving, brutal market competition. A terminal session grants deep, almost completely unfiltered control of the operating system to whoever is actively typing the commands. Now, this introduces a significant operational paradox. By stripping away the browser sandbox to gain utility, you expose the host machine's root-level files and system memory to direct exploitation. Developers are currently flooding open-source marketplaces, downloading thousands of pre-packaged AI skills to accelerate their build times. But executing an untrusted AI skill locally is risky. You are deploying an unknown executable equipped with its own capacity to parse and react to your data. A poorly written or intentionally rogue skill can autonomously search your file system, locate your environment variables, and exfiltrate sensitive data to an external server. Running these scripts without auditing them is equivalent to handing over root access to a total stranger. To remain competitive in output speed, engineers are forced to utilize these agentic tools, despite the severe execution risks they carry. Consequently, the core responsibility of a modern developer is pivoting toward rigorous local security management and the precise orchestration of these skills. Agentic AI provides a significant expansion of engineering output. Mastering it requires absolute maturity in how we delegate and command the machine's lowest-level permissions.